Continuing along, let's take a look at the next example. The time per workout an exerciser uses a stair climber is normally distributed with a mean of 20 minutes and a standard deviation of 5 minutes. So let's go ahead and copy that down. The mean is 20 minutes. And let's see, the standard deviation is 5 minutes. Okay, so on this first one, they say, of 500 members who use a stair climber, estimate the number who will use, and on this first one, the stair climber for less than 5 minutes. So we can go ahead and draw a quick picture with our 20 in the middle, our mean, and then what we're looking for, which on this one is how many people will spend less than 10 minutes. Here's our 10 minutes. Less than means we're going to be looking at finding the area to the left. So we'll start off by doing, just like before, our normal CDF. Remember that it starts off by going towards negative infinity forever, so we'll actually start out with a negative 10 to the 99th instead. Comma. Now our graph stops, or our area stops at 10. Remember, that is not a z-value, so I need to give it a little bit of extra information. I need to give the mean, which was 20. And last thing I also need to give it that's extra is the standard deviation, which was 5. Close that off, and let's see what our calculator tells us this value should be. Notice when you do this in your calculator, you'll get a 0.0228. Well, that's your probability of landing in that left-hand side, having used the stair climber for less than 10 minutes. Now, we still wanted to know one more piece of information, which is of our 500 members, how many are going to land in that group? So I need to still take my probability I just came up with and multiply it by our 500. So we'll take our 0.0228 times our 500 people that we have, and that gets us 11.4. So we'll round that to the nearest person and say that that's going to be a total of 11 people. And that's how many of the 500 will land in that group of using the stair climber for less than 10 minutes. Now let's take a look at B. We want to do a similar type problem, but we want to look at how many people will use the stair climber of the 500 between 10 to 15 minutes. So we'll start off with a similar picture, except for this time we've still got the mean in the middle, the 20. But this time we're going to use 10 and 15. So we've got our value, our first value 10, and our second value 15. And just like before, we want the area in between. Okay, so we'll still do a normal CDF. But this one's going to start at 10. And then it will continue to where it stops at 15. Again, just like the last couple, we have not had any z-values and we have not been converting them. The calculator's doing it for us. So we need to also, just like the last few, give the mean and also give, comma, the standard deviation, which was 5. Close that off and let's see what it finds for our probability here. What we get is 0.1359. That's our probability of someone spending between 10 to 15 minutes using the stair climber. Now I still have to put this in context and multiply it by the total number of people we have, which means we're going to take that value and multiply it by the 500 people we have. And let's see what that is. We've got our 0.1359 times our 500 people, which is our 67.95. So we'll go ahead and round that to 68 people. of the 500 will actually end up using the stair climber between 10 to 15 minutes. So what we've been doing is using our normal CDF to find the area. Remember, when we had Z's in the last section in 6.1, we would take something like 0.44, find the area to the left or below it by taking a normal CDF and we'd start off by, well, if it starts off going towards negative infinity like this one did, we started out with a negative 10 to the 99th, comma, we ended off at our stopping point at 0.44. And if we had Z values like we do in this one, you would just stop it right there and have our calculator do the calculation for us. What we came up with using our calculator was 0.6700, which meant that if we were to translate this, 0.67 would mean that 67% of the Z-scores fall below that value. Okay, so that was just a quick reminder that when we had Z values, it was a lot quicker. We didn't have to provide any extra information, and we were just all set to go. So we've talked about using two different functions, the normal CDF to find areas or probabilities, and we talked about doing the reverse. If you already have an area or probability and you want to find the Z value, meaning you're going in reverse, we talked about using the inverse norm function. So let's do one of those as a reminder.